Okay, the next operation is going to be spot drilling. So we're going to go to drilling, select from our tool library our spot drill, 3/8 diameter. We're going to have to do these in two different routines because how we're going to treat these is a little different, because this is a hole that's bigger than the diameter of the spot drill. So we're going to go to geometry and we're going to select just the chamfer. On height, we're going to go from model top, and we're going to go from hole top, but also this one, instead of going to hole bottom, we don't want to go that deep. We're going to go to hole top also, and then we're going to put a negative value in. So we're going to put in negative 0.125, and so we're making just a dimple that's wider than the web of the drill that's coming in next. Okay, and the next tab, we are going to do deep drilling. It's going to only take 2 pecks, but we'll do deep drilling, and that makes sure it clears any aluminum out of that spot drill before it goes to the next hole. Alright, so now we're going to do the same thing. We're going to go, we can basically duplicate this routine, and we're going to edit, and we're going to just clear out the geometry and pick a different face, which would be this countersink here. And then on the heights tab, we are going to clear out this offset, and we are going to go from hole top to hole bottom, because that one will control the depth of where we want it to go. And on the linking tab, we'll keep all that at default, hit OK. Alright, so there's our 2 spots. Okay, next we're going to drill through the center here. Okay, we want to do that pretty much right after we've made this concentric. So we're going to go drilling, and we're going to need to modify the drill that's used. So we're going to go to the revision 1 library, and we are going to use the 1/2 inch drill, but we're going to modify what's used just for this setup in this program. So do not change your main library. We're going to edit just this tool within this instance. Okay, so we are going to use a 1/2 inch. We need to use something longer because this one isn't long enough, and it has a larger shank than what the diameter of the drill is. So we're going to use a high-speed steel. So let's put in HSS jobber length drill. Okay, it's a lot longer. It's not going to be Kennametal, so we're going to delete that. So it's going to be a high-speed steel, cheaper drill bit. Okay, on the cutter side, what we need to do is we need to change our overall length is going to be 6, and then the length below holder is going to be 3.5, and our shoulder length is going to be 3.25. Our flute length is 3.25, so this is a much longer drill, and our drill point is 118 degrees because that's a standard drill, not a high speed steel or high performance drill. Okay, so now we're going to go to the shaft. Oh, and our shaft diameter is the same, so 0.5. Also change the material dialog box from carbide to high-speed steel. Okay. Alright, so then we go to the shaft, and there was a custom shaft made on this. So we're just going to set that at 0.5 also. So when you're all said and done, this should look like all the same diameter. Okay, on holder, we're going to leave it the same. Cutting data, we're going to leave it the same. Post processor, let's put a note. Special long length drill. Okay. Except we want to make sure you need a longer drill. We don't want to be crashing it using the carbide drill, so we need to control that. We're going to leave the feeds and speeds the same. They seem to behave pretty well. And then we're going to go to geometry, and we're going to select the countersink, the hole, and the countersink on the opposite side so that we go all the way through the part. In our heights tab, we're going to go from model top, Then we're going to go to from whole top to whole bottom for the cutting. We do want to break through, and we want to go 0.1 deeper. That way make sure we clear all the way through the part. On the next tab, we're going to do deep drill cycle, and we're going to leave this at default and hit OK. Alright, so there's our 1/2 inch drill. Now we're going to drill and ream this hole. So let's go back to drilling. We're going to select from our tool library the standard number 9, which is the letter D drill. Leaves enough clearance for a 1/4 inch tap. Should be able to leave everything here at default. Geometry wise, you're going to pick the countersink and the hole itself. And on the heights, again, we're going to go to model top, and then you're going to go whole bottom. We want to break through so the drill tip goes the correct depth, and we're going to go 0.1 deeper. Okay, we want to make sure that our reamer doesn't hit bottom. Okay, so you should have built up a reamer in another assignment. There's a video attached to this assignment on how to do that. It's been used on several different projects. Mine's already built up, so I'm going to go to drilling, and I'm going to select from my library my reamer that I've created, and leave all the speeds and feeds in default if you built it to the stat sheet. Under geometry, we're going to select our hole and our countersink. Under cycle, it's reaming, so we just leave that as and hit OK. Alright, now all we have left is chamfering. 2D, chamfer, and we're going to get from our aluminum library the 1/4 inch chamfer mill. We're going to leave everything on the first tab at default. We're going to go to geometry, and we're going to pick the top of the hole, the top of the boss, the top of the second boss. So those 3 loops, make sure the arrows are all on the correct side of what you picked. Heights, we're going to go from model top and model top. On the next tab, we're going to bump our chamfer tip offset to 80 thousandths. We'll go ahead and check smoothing. And then we're going to go to linking tab. We're going to leave all this at default. And we'll hit OK. Okay, congratulations, you're done programming this. Remember, you need to submit setup sheets and NC code in the assignment for both operations.